I want to talk a little bit about scaling tech teams. And when we are talking about scaling teams, and many of you are in this kind of process, I'm talking about a journey where we started Picnic with just a couple of engineers, 2, 3, 5 engineers a couple of years back. And by now we have a couple of 100 engineers and went through many, many different stages. And I want to share a couple of the learnings, but not only the kind of the lessons learned, but also especially the kind of the failures learned that hopefully you can avoid when you're going through a similar kind of journey. So I will not talk much about this vehicle, but if you look a bit around, we have now around 2,000 vehicles here, around 1,000 vehicles in Germany. So that is by now a little bit kind of a size. And if people are asking, what are you doing actually different compared to all the other kind of online food opportunities, then the main difference is that we have a new proposition, a proposition that nobody has tried before. We found a kind of an operating and a business model that makes it possible, that actually revolutionized the way how people buy food. And the business model itself is a relatively simple and straightforward one, where we say you can buy all the food you like at the lowest price and you don't pay delivery fees. It's pretty straightforward, very simple, but actually having a proposition that consumers like is not hard. Making it possible from a technology proposition, from an operational proposition is a much harder part, and I will talk a little bit about this. And if you look a bit behind the scenes, then there's a lot of technology. What you know if you're a Picnic customer is obviously the app on the left-hand side, but that is max kind of 5 or 10% of the technology that we're building. There's an entire platform, logistical platform behind the scenes about buying products, fulfilling products through a kind of an entire set and sequence of warehouses up to the kind of the last mile proposition that you have with the cars. And that is kind of 85% of the tech stack that we have built. And that is also the real kind of magic behind the scenes. So before I will dive in a bit in the lessons learned and what we actually take out of it and what can come next, let me show you a small video to just see a bit on how the team is working on a day-by-day basis. Technology, and when we are kind of reasoning and designing tech teams and technology, then there's one thing what we always keep a bit in mind, and that is also something when you're thinking a little bit about the right scale structure and the right kind of leadership team that you need to think a bit about is, then you're building technology that is fulfilling a need, hopefully today's need, but even more important, tomorrow's need, with the technology that is tomorrow available. So let's go once again very slowly about that. So that means you're essentially, if you're deciding about a technology direction, about a team organization today that actually needs to fulfill the requirements of tomorrow, and both from a consumer and from a technology side, which means also you need to actually take very much into account all kind of technology advancements, kind of expected technology advancements. So in the current time, for instance, with generative AI and many kind of those kind of trends that are so much accelerating all the stuff that we are doing, it is very important to extrapolate how will the world look like roughly in 6 months, 12 months, 18 months, 24 months time. Obviously, nobody knows exactly, but it's all about setting up the kind of optionality that you can really be best prepared for such a future. And when we are looking a bit back, so then a team started usually as a relatively small team. And at some point, you're reaching a size of around 20 engineers. And at that point, it becomes really interesting. Beforehand, there's actually very little organization. There's essentially the only thing what really matters is that everybody feels ownership and has ownership. But when you have 20 people, then you have the kind of the first interesting challenges. And let's go a little bit over the kind of the challenges that you need to tackle at this point of time. Actually, very cool challenges. I think all of us are in technology because we love to solve those kind of challenges. But the first thing is you have enough people that you have the first time conflicting priorities. You had never kind of conflicting priorities. You had only kind of conflicts between do I do it or do I not do it? But now actually you have enough people where you can really decide a bit on what am I working with kind of my 20 people and what am I not really working on. But the second one is also because you have already built all kind of stuff, product quality starts to become a real issue. You need to think a bit about how do you maintain quality? How do you think about regression? If you have nothing before, then obviously regression is not really an issue. If you have now already a little bit of kind of a product stack, if you have a team that is building something, then product quality becomes a really interesting one. However, on the other hand, you're still so small that hiring senior talent is still kind of a challenge. And then you're still taking all kind of shortcuts. So that's a kind of a very interesting time. We are starting to form a bit on how your kind of tech organization, and you're setting up a culture that hopefully allows you to still scale as fast as possible, but starts to set the kind of the first seed and for the kind of engineering excellence that you hopefully have at this point in time, but you certainly need at a later stage. So if you go a little bit further, then at some point you go through the final phase of 30 and 40 people. And at this stage, you're just realizing if you are at 40, 40 is not twice as much of 20. You're actually exponentially increasing kind of complexities that you have in a team. So the first thing what you just realize is you're now running actually all kind of different teams. So all kind of Scrum teams and work streams. You have all kind of different priorities. And what you realize is that the dependencies between those kind of different teams are becoming so complex that deadlines start to slip. Actually, fun fact, they slipped also before, but you just didn't realize it early on because basically everything was in movement. But at this point, because you do a little bit more planning, you just start to realize that some of the deadlines you're simply no longer making because you have stakeholders that remind you that deadlines are slipping. And then you have also the first time some form of business challenges, and combined with those kind of business challenges, you have a very interesting effect. People know a lot in your organization, but you start to actually have built some knowledge silos because you're usually then 2, 3, 4 years in the journey. And those kind of people that have been there between since day one versus those that have just joined maybe for the last year or the last 2 years are actually becoming kind of a two-class citizenship in your engineering team. So you need to think very carefully about how do you break through this kind of cycle that you have this kind of early engineers versus the engineers that more recently joined. And by the way, every tech organization in Netherlands, Europe, etc., has exactly the same problem. This is not just picnic, but this is also, if you go to an Adyen or Booking, etc., you have always this kind of conflict between the early employees or the early engineers and the engineers that joined a little bit later. But what is actually the real challenge that you have at this point in time, and you will see this even more, is that at this point in time, engineering becomes so strong that kind of the engineering and the business teams are getting a little bit apart. So that means they are no longer so well connected. And at this point in time, you hear the first time on the floors, the people starting to ask, what is actually engineering doing? What are those kind of tech guys doing? And there are two reasons for this. Number one is communication is a little bit harder. But the second one is also because you have diminishing returns of your first product versions. Actually, your product is not moving any longer so fast. So therefore, the change of improvement is no longer visible in the way as it was visible in the early days. But this is all still manageable, and with better communication, better closer connection, etc., is still kind of, you can keep the organization together. And then you grow further and you end up at a size where you are 60, 70, 80, and you reach actually a pretty nice and nice little team where you see that at this point in time, you have actually the first time in need for more organization because you have actually now reached a size it becomes so hard to do some planning that you need to think about domain ownership. And domain ownership is not only that you have a couple of different kind of products, but that you think about a KPI model where everybody can, in clear terms, measure a bit what is my contribution, what is the contribution of my team, but even more, also what should I not work on. So the most important tool, if you have kind of 80 people, is no longer kind of to-do lists or roadmaps or plans, which we have been already obviously doing earlier. But actually, at this point in time, you start to build not to-do lists. So not to-do lists are actually offloading your brain in a very meaningful way, because you start to actually say, there's a lot of kind of priorities and a lot of stuff that we should do. But at this point in time, you start to really build kind of lists of the things that you should not do, at least not this kind of team week. But then you have the kind of the second challenge, because you have all kind of legacies. So you need to start to balance how do you tackle legacy versus kind of new developments, and consistency in your code base, because you have given a lot of freedom to your engineering teams, is obviously becoming a real challenge. So here you need to think a bit about which kind of balancing act do you go? Do you go the Twitter way, or do you go basically a very consistent code base way? So that is certainly a kind of an interesting challenge. But it becomes even more interesting because at some point you're reaching kind of 100, 120, 140, 150, 160. And here the real music starts, because at this point in time, you just realize, oh boy, now we are actually a serious tech team. Your CFO will also remind you, actually, you're spending quite a bit of money, not only people costs, but also with your cloud providers, etc. So this is now actually becoming a more serious business. And now the real fun starts, because now you're actually working with many kind of stakeholders. You have different kind of product lines. So that means you need to do a product line and program management. But also you need to actually think in a very structured way, how do you communicate to your stakeholders? You can no longer do the communication completely by yourself as leadership team or as leaders of your tech organization, but you have obviously kind of direct reports that you need to start communicating to your tech teams. And then you also start to realize that the complexity of your organization, of your tech stack is becoming so high that it's just no longer under control. So therefore, the most important trick, if you have kind of a few hundred engineers or more, is that you run very structural tech complexity reduction projects. That means essentially is that you, for instance, make your complexity much more narrow, but also that you get not only kind of the latest technology, but that you are more focusing on proven technology, and that you resolve this kind of conflicting interest that you have on an ongoing basis. So the most important thing, and that is basically the one message that I want to convey, is fighting complexity as technical leaders. This is your key objective. Tech is a people business, but fighting complexity is probably the only real tech stack and tech content responsibility that you have. Because essentially complexity is a kind of a drama that we have all as technical leaders, because we are in this kind of spectrum between, on the one hand, trying, and we also need to work with the latest technologies. We want to work with the latest technology, we want to think around. But on the other hand, it introduces a complexity, especially if you have the width of a broad tech stack, that you simply have a much harder time to manage. And the kind of a complexity comes from a couple of different factors, because you have definitely an engineer that is coming up with an idea. I saw this kind of new API, so we are using all kind of REST. Should we not use GraphQL? We have all worked with Mongo and Postgres. Why not using XYZ database and many other ones? And if you're more on the DevOps side, then obviously all kind of observability tools and monitoring, alerting, and whatever kind of stuff. There's a lot of cool stuff that is happening here. And the real risk is, or the real challenge is, that you end up with very broad kind of tech stack. So for instance, in Picnic, at some point, we had simply 150, 170 different kind of tools for all kind of different things, which made sense if you take a kind of best of breed. But actually best of breed is very nice on paper, but makes it super complex to get a consistent and scalable kind of tech stack. So therefore, it is much easier sometimes to have not best of breed. Forget about the best one. You want to have the most integrated one or the most compatible one with respect to your total complexity stack. So therefore, you have also on the architecture, obviously, all kind of complexities. So everybody is then obviously talking about microservices, and microservices are cool, and you should have microservices. But actually, microservices introduce a complexity in some areas that is just not justified. So therefore, actually, I would go the other way around. Sometimes actually monoliths are super cool. And maybe just one other thought is, if the complexity on the effort of building new software systems with generative AI or Copilot and those kind of systems is actually getting much lower. So that means the effort of building a new system is reduced significantly, then it is very likely that in many cases it becomes easier to build a new system instead of building an architecture, a complex architecture that you can easily reuse your implementation. So therefore, the entire kind of pitch for microservice architecture that you can reuse in a very easy way, that it becomes very easily scalable, becomes less relevant in a world where maybe software development of a new system is only 0.1 or 0.01 kind of the effort of what it was before. But nonetheless, the most important thing is you need to know a bit your enemy. And let's think a little bit about how a typical kind of software development, what is driving complexity. So complexity of a software development process is, there's all kind of legacy, so stuff that you had before. Then there is certainly a solution complexity. You can't do too much about it. And there's certainly some form of a domain complexity. But the only thing what you really have is a domain complexity. Everything else you can basically fight. So a typical first project looks like you have some form of solution complexity. So there certainly is a part of the domain, but also solution complexity, and you can decide how complex it is. And then you have a kind of a second project. And the second project is, well, somebody comes up with a kind of a new idea. There's a kind of a new technology. So let's use just another technology. Let's try something out. So therefore, you have more solution complexity, twice as complex. a kind of old implementation, new implementation, because you wanted to try maybe a new database, you wanted a new observability, etc. And then you end up in a kind of a stack where you have a third project, which is actually adding to this entire solution complexity. So the solution complexity piles on top of each other, while the domain complexity, what you're trying to capture, is still a kind of a constant factor. So therefore, you're introducing a kind of a complexity in your system by trying out new things that becomes even harder to manage. So at some point, you have so much kind of solution complexity, legacy complexity, which is something what you don't want to have, which is something what is avoidable, because the only real complexity driver should be domain complexity, so that you end up in a stack that is actually most likely much more complex than if you would rebuild this. So the only real equation when we're looking to software complexity is the way how we assess this is if you would start again from scratch, if you would essentially rebuild the entire system from there now again, where we can hopefully tackle very well solution and solution complexity and legacy complexity. So the only thing what is left is domain complexity. How would the system look like? And I think that is a kind of a key message and a kind of an ask to you is just think about if in whatever environment you're working, how would your software system look like if you would build this exactly again from scratch? And usually you come to a very different type of implementation. And the solution to this is obviously also the other way around. Just restrict your tech stack. If for every single problem, there should be only one solution in your tech stack. So there's only one observability tool, only one kind of document database, one relational database. Don't try all kind of fancy stuff. If you cannot, you can basically scale most of the technologies in a way that you can apply it to a kind of a complexity. And that means not only one, but also pick a very simple one. So we, for instance, at the beginning, looked at Picnic, looked in all kind of languages, and there was Scala and all kind of fancy stuff, and Go and Rust and blah, blah. Actually, we have chosen Java. Not super sexy, not super cool, was definitely not the kind of the thing that was hip and happening at this point in time, but it avoided a lot of kind of complexity because it was a stack that existed at this point in time already for 20 years. So therefore, and that is a little bit kind of the message behind this, if you're making a kind of a choice that the kind of the short-term gains of new technologies often will not be outweighed by the long-term maintenance complexity that you have there. And that is something what especially you as technical leaders are responsible for, to keep your tech stack kind of the complexity and the solution complexity of the tech stack as low as any possible. So then the question is, how do you keep your engineers excited? How do you make everybody excited about working with a kind of a narrow tech stack, maybe a little bit boring tech stack, etc.? And the solution for this is you need to make sure, and that is especially together with your product people, they need to fall in love with your product solution. Not so much with the tech that you work with, which is cool, and obviously we are all technologists, but you need to fall in love with the solution that you're working on. So let me show you, just to close up, maybe one kind of area where we have applied it, and it is our automated fulfillment center. So what you see here is an order picker that in our manual fulfillment centers is doing the order picking in a manual way. So that means you pick basically in a manual way the cucumbers, bananas, etc., and go through shelf locations. But if you think a bit about it, it's not efficient because you go a long ways in a fulfillment center, usually 20, 30, 40 kilometers per day, to just find all the kind of products. So a much smarter one is actually that you get the products the other way around by robots that are brought from the storage location with a robot to the pick location. And let's have a quick video to see a bit on how our first generation fulfillment center that we have launched last year looks like. So this is such a fulfillment center that we have actually built on pretty boring but very relatively well-established technologies. In the sense of, this is an on-prem stack, this is VMware, this is an older version of Java, that is not kind of fancy reactive programming, etc. But that is basically programming that has one very, very important advantage. On the one hand, it is certainly a proven kind of pattern and technology that we are using, but even more, because it is so standard, it allows basically all engineers to work on it. So we have 350 engineers, and there are a few engineers that know the latest Rust and Go and whatever kind of stuff. But everybody knows basically a Java 11 or Java 14. So if you're using something which is a little bit more established and not totally cutting edge, you create a lot of flexibility in your entire engineering team. You can pretty easily and well balance between your different kind of projects. So there are kind of three kind of messages or takeaway things that I want to share with you. First one is, at some point you need to obviously think a bit about how do you organize your organization, how do you reorganize. And at any point in time, you probably need to do, when you're growing from a few engineers to a few hundred engineers, you probably reorganize every 6, 9, 12 months your engineering organization. But one thing is, every consultant will tell you, make it proactively, don't make it painful, etc. But actually, we did it completely opposite way around. What we did is we actually did it as late as possible. And the reason for this is the following. If you're growing super fast and if you're actually building a lot of kind of experimental technology, experimental business processes, you just don't know exactly what you will need in the next 3 months or 6 months, etc. So therefore, it is in those kind of cases, especially if you're in a very fast-growing environment, if you're working in a very experimental environment, it is easier to wait until it really hurts, and it needs to really hurt, and then you start to optimizing your organization, or better, then you're reorganizing in a way that you solve the problems that are at hand. It's very hard in such an environment to know upfront what do you need to solve. And the second one is obviously also, you need to think a little bit about how do you organize your technology stack and your organization. I think what is very helpful is that you have a scalable tech stack. Think in a very structured way, and you as technical leaders should think even more, not so much about the functional roadmaps. That's all your product teams and functional business stakeholders do this. You are responsible for non-functional properties of your system, so the scalability, resilience, security, etc. But even more, think about organization as an evolving topic. And we know also that tech systems are following a bit the org structure and the other way around. So you need to think very carefully about which kind of organization you set up, because your tech system at some point will model exactly what you have set up on the organization side. And the third one is, at some point, and for some organizations that is at the size of maybe a few dozen, at some points it's a few hundred, maybe at some point 1,000, your responsibility is all about efficiency. And efficiency doesn't sound cool. So you're not talking about developer efficiency. That is not a term that people are using. But there's a much nicer term there. You can talk about developer enablement, developer flow. And that is something what is your real responsibility. And that is all about, and now in quote, taking away as much as possible obstacles from your engineering team. So we made recently just a very simple study where we said, okay, how much time can actually engineers spend really coding, really working on the actual code, etc. And you have all kind of indirect measures for this. So how much meeting time do you have? How much time do you not do something in your ID, etc. And you can see that the most important thing is actually that you find a way to have enough free blocks or blocks where engineers can uninterrupted work in a week. So one thing that works for many organizations already is that you just have a meeting-free day. So that is certainly helpful, but this is usually very drastic. What helps even easier is that you block maybe just 2 or 3 mornings or 2 or 3 afternoons in the week where everybody is fully focused on making deep work. And this kind of deep work is so much more productive than all the other interrupted work that you will see that you need usually in a typical work week only maybe 2 half days of deep work, that 80% of the work that should be done in the week can be actually realized. And that is something, if you can structure this organization and from a tech stack perspective, then you're already a big step forward. So that were basically the 3 messages that I wanted to share with you. Thanks a lot for your attention.